Hello there, friends and lovers. This is a very short video that I put together on how to set up models and really any visual element within Starcraft 2 to make use of gloss maps and simulated roughness. The TLDR is that gloss map layers within a material have to be set to raid a singular channel. So whether that be red, green, blue, or alpha is fine, but having it set to read by default RGB or RGBA, the map will fail to be read correctly. Very quickly, I'm just going to run through the texture map setup in Photoshop. Of course, you can do this in GIMP or whatever other photo editing suite that you use. It's probably not very important if you're already familiar with the process, but just for the sake of completion, I'm going to go ahead and show it here. So with this firearm model, we have diffuse textures, baked ambient occlusion, specular, gloss, and then a normal map. For the diffuse map, I like to duplicate the ambient occlusion bake, paste it on top of everything, and multiply just to get that nice self-shadowing baked into the diffuse map. For the specular map, in this case, it's monochromatic. The gloss map is always going to be monochromatic as well. Both of these could technically be packed into the red and blue channels of the Starcraft 2 normal maps, but just to keep things separate, I'm going to have specular taking up RGB, and I will be duplicating and then pasting the black and white gloss map into the alpha channel of the specular map. There are no steps out of the ordinary to perform on this normal map that you would normally perform on any other Starcraft 2 normal map. So I will invert the green channel, I'll copy the red channel to the alpha channel, then I'll fill the red channel with white and fill the blue channel with black. And that's it. All the textures are ready to go and have all been saved with the direct draw format. We're ready to move over to Blender and set up the actual model. So again, in Blender, there's not a lot of steps that are out of the ordinary for setting up any other M3. I will import the OBJ of the firearm model and create a new armature, which the model will be parented to. I'm also going to make some transform changes to this model just because my work environment is different, but you probably don't have to do that. We'll go ahead and parent the model to the bone. I'm going to add an edge split modifier because this model makes use of a calibrated normal map, and you want to make sure that your smoothing groups are intact when you export the model as an M3. M3 does not store smoothing group informations, so to force sharp edges, you need to create mesh splits, and that's what this modifier is going to do for us. Additionally, I'm going to create a vertex group just to weight the entire model to that bone, which it's parented to. Now we want to create the material which will be applied to the model and make use of simulated roughness. So we're going to create a standard shader, and within that shader we want to create diffuse, specular, gloss, environment, environment mask, and a normal layer. On other models, you may be making use of an alpha or emissive or something like that, but in the case of this model, these are the only ones that I need. I'm going to go ahead and add all the image path entries for where the textures will be located. For this test, I'm just using the root directory, but the location may be different in your project. The two critical things that need to be taken care of to make use of simulated roughness in Starcraft 2 is one, that your gloss map layer is reading the texture from a singular color channel. So in this case, the gloss map was packed into the specular map's alpha. So here I'm changing the channel to alpha. And two, you need to be sure that the environment mask's UV source is set to reflection cubic environment away from the default of default. Once the material layers are all set up, you're going to want to increase specularity to around 1,000 or so. You're also going to want to increase specular HDR. In this case, I use 2, but higher values also work just fine. And lastly, you're going to want to make sure to tick on simulated roughness within the material settings. We're just about ready to export the model to make use of it in Starcraft 2. You will want to make one small change though to the export settings for the M3, and that is to increase the standard material version to 19 or higher. By default it's 18, and in this case I've set it to 20. We'll just apply the material to the model and export it as an M3. So here you can see the model has been imported into Starcraft 2, and I'm just looking at it in the cutscene editor right now. This is with all the textures applied and making use of simulated roughness. The big things that stick out to me is that you'll notice kind of the plasticky or the polyurethane materials of the magazine or the stock or the handle react quite a bit differently to the lighting than say that of the receiver or maybe the iron sights. Making use of a specular as well as an environmental reflection map can already be pretty powerful in StarCraft 2 in terms of how your model or your character or whatever your custom asset is lit within the game or within the editor. But being able to further control that reflectance using simulated roughness using a gloss map is icing on the cake. I believe that simulated roughness was added as a rendering method sometime around 2015 or 2016 to StarCraft 2, and very few existing Blizzard assets actually make use of gloss maps. And I think it's unfortunate that simulated roughness was added so late into the lifetime of StarCraft 2, because it really is a striking effect and it really adds a lot just to the overall quality and fidelity of models. That's it though, working gloss maps within StarCraft 2. I think I made this video more for myself just so I could remember some of the minutiae, but I hope that it's also been helpful for you.